For thousands of years, ancient civilizations built remarkably different kinds of boats to cross rivers and oceans long before modern tools. So in today's video, I'm going to count down 15 incredible ways that ancient people navigated the seas. Let's start with number 15, the reed boats of ancient Egypt. Some of the earliest known seafaring vessels in human history weren't made from wood, they were made from bundled reeds. Ancient Egypt, with its abundant supply of papyrus along the Nile River, produced reed boats for thousands of years. These vessels were simple in construction yet remarkably capable for their time, allowing Egyptians to travel along the Nile, carry goods, fish, and even venture into the Mediterranean. Reed boats were built from tightly bound bundles of papyrus stalks, layered and shaped into long, curved hulls. The ends often rose upward, which was a form that helped them glide through the water while reducing any drag. The bundles were tied together with plant fibers or rope, which formed a solid, buoyant structure. The boats ranged in size from small fishing craft to larger vessels that were capable of transporting multiple passengers or even cargo. For navigation, the boats relied on simple but effective methods appropriate for river travel. The predictable currents of the Nile allowed the Egyptians to drift downstream with ease, while paddles, poles, and later simple sails did enable movement upstream. The earliest sails on these reed boats appear in artwork that date more than 5,000 years ago, indicating that Egyptians were experimenting with wind power earlier than many neighboring cultures. A single square sail allowed them to capture favorable breezes, which was especially useful during certain seasons. One of the coolest aspects of these things is their durability. Although papyrus is a plant material that does degrade quickly, the density of the bundles and the natural waterproofing of the stalks made them surprisingly durable. For long voyages into the Mediterranean, these big wooden ships eventually replaced the reed construction, but reed boats continued to serve essential roles. Modern reconstructions like Thor Heyerdahl's Ra and Ra II expeditions in the 20th century show that these boats, built by using ancient techniques, could handle open sea conditions way better than previously assumed. Number 14. The Phoenician Bireme. Among the most influential seafaring vessels of the ancient world was the Phoenician Bireme, an oared warship and trading vessel that helped establish the Phoenicians as one of the greatest maritime cultures of antiquity. Originating around the 8th century BCE, the Bireme featured two levels of oars, one above the other, which allowed it to achieve a much greater speed. Phoenicia, a region corresponding to roughly modern Lebanon and parts of Syria and Israel, lacked large agricultural lands, but they had access to prime coastal timber, especially cedar. This encouraged the Phoenicians to become shipbuilders and sailors. The hull construction involved mortise and tenon joints, which is a technique where precise grooves and pegs lock the planks together. This kind of craftsmanship made Phoenician ships strong enough for long voyages across the Mediterranean. But the defining feature was the two-tiered rower layout. The lower rower sat deep inside the hull, while the upper rowers were positioned slightly outward and above, giving the ship a compact yet powerful propulsion system. This design allowed the Bireme to travel much faster than contemporary vessels, and the addition of a small square sail did provide auxiliary wind power during longer journeys. Archaeological finds and classical sources do confirm that Phoenician sailors were transporting goods like glass, textiles, purple dye, timber, and metalwork, and their ships helped them establish colonies, including Carthage, which later built its own powerful navy. These ships also played a role in early Mediterranean warfare. Its speed allowed it to be used in ramming tactics against enemy ships. A reinforced bronze ram fitted to the prow gave the Bireme a weapon that, combined with coordinated rowing, could break the hull of slower or poorly maneuvered ships. Although later Greek and Roman navies developed triremes and more complex warships, the Bireme laid the foundation for these multi-level oared naval vessels. With the Phoenicians and their seamanship impressing neighboring cultures to such a degree that Greek historian Herodotus credited Phoenician sailors with circumnavigating Africa, which is a claim that's debated by modern historians, but it's indicative of their reputation. Number 13. The Polynesian Double-Hulled Voyaging Canoe. Among the most remarkable vessels of ancient history are the double-hulled voyaging canoes of Polynesia. These ships enabled some of the longest open ocean migrations ever accomplished before modern navigation, allowing Polynesians to explore and settle the Pacific Ocean. That's an area larger than all the continents combined. A double-hulled voyaging canoe consists of two long, narrow hulls connected by crossbeams and a platform. This structure has exceptional stability, reducing the likelihood of capsizing in rough seas. The design does also distribute the weight evenly and allows for a substantial cargo capacity, including water, food stores, tools, and passengers. This balanced design gave Polynesian voyagers the reliability needed for these journeys that lasted weeks or months. The hulls themselves were typically carved from large logs, breadfruit, koa, or other strong woods, and they were lashed together using coconut fiber rope, which is highly resistant to salt water. A platform between the hulls provided some space for navigation, sleeping, storage, and sometimes small shelters. A large triangular or cab claw sail made from woven pandas leaves allowed the canoe to harness prevailing trade winds, and those sails were adjustable, enabling the sailors to manage direction and speed. But what also made these things extraordinary wasn't just the engineering of them, the skill of the navigators too. Polynesian sailors read stars, they listened to the winds, the ocean swells, bird flight paths and cloud formations, and even sea color changes to determine direction and position. Voyagers used consistent wind patterns like the Pacific trades to move between island chains like Tahiti, Samoa, Tonga, and eventually to remote locations like Hawaii, New Zealand, and Easter Island. Historical descriptions from some of the early European explorers like Captain James Cook praised the sophistication of these canoes. Cook noted that some vessels could reach lengths of over 30 meters and carry dozens of people. The combination of their navigation and engineering impressed Western observers, many of whom underestimated how advanced the indigenous Pacific maritime tech actually was. Modern reconstructions, most famously the Hokulea, have successfully completed long voyages across the Pacific using only these traditional methods. These voyages validate the historical accuracy of their seafaring capability, and they show that the double-hulled voyage canoe was not just functional but highly efficient. They were practical, reliable, and perfectly adapted to the world's largest ocean, proving that ancient mariners could cross huge distances with amazing precision long before modern tools existed. Number 12. The Greek Trireme. The Greek Trireme is one of the most iconic warships of the ancient Mediterranean, and it represents a major achievement in naval design. Developed around the 6th century BCE, the trireme became the backbone of Greek naval power, particularly for Athens. Its engineering was focused on speed, maneuverability, and coordinated rowing, features that made it effective in battles and capable of handling long coastal voyages. Now, the defining feature of one of these is the 3 tiers of oar, hence the name, from the Greek trirees, meaning 3-rower. Each level housed a single rower per oar, arranged in a staggered formation to prevent any interference, and this system allowed the ship to generate immense power through human rowing. Speeds were significant for the period and essential for the ship's primary tactic, which was ramming. Now, these triremes were long, narrow vessels, typically around 35 meters in length and only about 5 meters wide. Their hulls were built with tight-fitting planks joined by mortise and tenon joints, which created a lightweight structure. Naval battles during the Persian Wars and Peloponnesian Wars confirmed how decisive a tactic like ramming could be. The Battle of Salamis in 480 BC, one of the most famous naval engagements, saw Athenian triremes use their speed and maneuverability to defeat much larger Persian fleets. Although they were built for combat, triremes were also used for patrolling, transporting officials, and conducting long-distance expeditions. They weren't ideal for open ocean voyages, and they were rarely used far from any land, but within the Mediterranean environment where most travel happened near coastlines, they performed exceptionally well. Triremes did also carry a small sail for some longer journeys, usually a square sail mounted on a single mast. That mast could be lowered during battle to avoid obstruction, and supplies, however, were limited due to the narrow design, meaning triremes often had to beach at night for rest and provisions. While no complete ancient trireme survives, discoveries, reliefs, and written descriptions, combined with some modern reconstructions, like the Olympias, provide detailed insight into how they functioned. Today, the trireme is widely regarded as a symbol of ancient Greek maritime innovation. Number 11. The Viking Longship. I love the Viking longship. It's one of the most recognizable and influential vessels of the early medieval period, used by Norse sailors for trade, exploration, and warfare from roughly the 8th to the 11th centuries. Its design combined speed, flexibility, and seaworthiness in a way that allowed the Vikings to travel farther than nearly any other ancient seafaring culture of their time. Longships were narrow, lightweight vessels constructed using the clinker or lapstrake method, in which overlapping planks were riveted together. This method produced hulls that were strong and flexible, which allowed the ship to withstand rough seas. A typical longship could be between 20 and 30 meters long, though there are some famous examples, like the Roskilde 6 measured more than 35 meters. A single square sail made of wool, often dyed red or striped, provided wind power, but longships also featured a full complement of oars for rowing. That combination allowed the crews to switch between wind and manpower depending on the conditions. In the open seas, the sail was crucial for long-distance travel, and near shorelines or in narrow rivers, the oars provided greater control. Longships also had a shallow draft, less than 1 meter, which allowed them to navigate shallow coastal waters and river mouths that deeper vessels couldn't. The steering system, too, was another distinctive feature. Instead of a central rudder, longships used a steering oar mounted on the starboard side. This system gave a skilled helmsman remarkable control, especially in rough water. The symmetrical bow and stern allowed it to reverse direction without turning around, which was valuable also in tight waterways. Excavations reveal that longships were constructed with great craftsmanship. Iron rivets, carefully shaped planks, and carved decorative elements show functionality and artistry. Many longships also carried shields along their sides, both for defense and as a form of identification or intimidation. But today, longships are regarded as some of the most advanced vessels of their era. They were fast, adaptable, and perfectly suited to the maritime lifestyle of Viking society. Number 10. The Roman merchant vessel. While Roman warships like biremes and triremes are well known, the workhorses of the Roman economy were the merchant vessels, commonly referred to as corbettae. These ships formed the backbone of commercial trade across the Mediterranean during the Roman Republic and Empire. They were designed for carrying cargo rather than speed or combat. They were engineered to be stable, durable, and capable. The hulls of these ships were built using the same mortise and tenon technique, and this construction created exceptionally strong joints. The corbettae typically featured a broad beam and a deep hull, which increased their storage capacity, and many were capable of carrying hundreds of tons of cargo, which was a remarkable figure for the ancient world. The propulsion system was a large square sail mounted on a single mast, and a smaller sail on a short forward mast improved maneuverability too. But unlike warships, corbettae didn't rely on oars, except for small adjustments near the harbors. Their broad shape and reliance on wind power made them slower, but way more efficient for transporting goods. The cargo carried by these ships included grain, olive oil, wine, pottery, marble, metals, and even textiles. Of course, Egypt's grain shipments to Rome, a critical supply that fed the capital, traveled in part on vessels like these. The size of the vessels did vary, but some were notably large. The Isis, described in an inscription from the 2nd century CE, was said to be one of the biggest merchant ships of the time, measuring over 50 meters in length and capable of carrying enormous shipments. Shipwreck studies, like the one off the coast of France, show similar large-scale cargo vessels, complete with an intact hull structure and thousands of amphorae. The corbetta was essential to sustaining the Roman economy. Without these kinds of vessels, the empire would not have maintained its vast trading network or even supported its population. The corbetta stands as a key example of how ancient shipbuilding enabled their economy to grow on a massive scale. Number 9. The ancient Chinese junk. The Chinese junk, it is one of the most influential and long-lasting ship designs in history, with origins tracing back more than 2,000 years. By the Han Dynasty, which is about 206 BCE to 220 CE, early versions of junks were already in use, and over the centuries they evolved to sophisticated vessels capable of river travel, coastal sailing, and long-distance ocean voyages. One defining feature of the junk is its fully battened sail. Unlike the square sails common in the Mediterranean, junk sails are made of multiple horizontal battens, typically made of bamboo sewn into cloth panels. These battens give the sail some rigidity while still allowing it to bend and flex in the strong wind. The sail's ability to be reefed quickly, which is lowered or reduced in size, gave the crews a greater control during storms or sudden wind shifts. But the hull of a junk is equally innovative. Junks featured watertight bulkheads, internal walls dividing the hull into compartments, and these bulkheads greatly increased the safety. If one compartment was punctured or flooded, the rest of the ship stayed buoyant. This concept appeared in China centuries before similar ideas appeared in Europe. Bulkheads also strengthened the hull, reducing flexing and making junks more resilient during long voyages. Navigation aboard the junks benefited from Chinese technological innovations too. Chinese sailors used the magnetic compass, a development that transformed long-distance navigation. Their stable hulls, strong sails, and compartmentalized design allowed them to handle monsoon winds and open ocean challenges safely. Archaeological findings, like shipwrecks from the Java Sea, provide physical evidence of early junk construction. These wrecks show clear signs of bulkheads, stitched plank hulls, and advanced joinery techniques. As an ancient vessel, the junk stands out for its stability, its advanced sail system, and it allowed China to become a major maritime power long before many Western nations developed comparable ships. Number 8. The Egyptian Khufu ship. The Khufu ship is one of the oldest and best preserved wooden vessels ever discovered. It offers a rare and detailed look at ancient Egyptian shipbuilding. It was unearthed in 1954 beside the Great Pyramid at Giza. The ship dates to around 2500 BCE. While it was likely a ceremonial vessel rather than a working seagoing craft, it shows exactly how large wooden Egyptian ships were built during the Old Kingdom. The Khufu ship is about 43 meters or 141 feet long. It's long enough to rival or exceed many classical ships built nearly 2,000 years later. It was made from Lebanese cedar, which is a prized material for shipbuilding. It was made using a shell-first construction method in which the planks were shaped and joined before the internal framework was added. And despite being discovered disassembled in more than 1,000 pieces, the ship was successfully reconstructed. The hull displays the classic crescent shape seen in many Old Kingdom vessels, with high ends and deep central curves. This form would have been effective for river travel on the Nile, although the exact seaworthiness of such ships remains a subject of research. Egyptians did conduct some seagoing voyages like expeditions to the Red Sea and the land of Punt, but whether those missions used ships identical to the Khufu design is uncertain. The vessel was equipped with oars and a steering system, which involved large steering oars at the stern. It also featured a central cabin or canopy. There is no mast or sail preserved with the ship, and experts debate whether the original vessel did carry one. Many Egyptian ships of the period did use square sails, but no conclusive evidence remains of a mast hardware were found in the burial context. But the importance of this Khufu ship lies in the construction of it. It shows that by 2500 BCE, Egyptian shipwrights had mastered long hulls and seagoing proportions. These skills were essential for their trade, transport, military expeditions, and exploration along the Nile and beyond. This ship provides a direct physical link to the early maritime development and remains one of the most significant finds in nautical history. Moving on to number 7, the Byzantine Dromon. The Dromon, it was the primary warship of the Byzantine Empire from roughly the 6th to the 12th century CE. Evolving from earlier Roman designs, the Dromon combined speed and tactical features that made it a dominant force during centuries of naval conflict. They were typically built using lapstrake or clinker method, where the wooden planks overlapped and were fastened together with iron nails or wooden pegs, and this produced a hull that was relatively light yet strong enough to handle the rough conditions of the Mediterranean. Most Dromons were single-hulled vessels with a long, narrow profile, generally measuring between 25 and 40 meters in length. One key characteristic was the mixed propulsion system. They featured 1 or 2 banks of oars and a large lateen sail, which was a triangular sail that provided excellent control. The introduction of the lateen sail is one of the major innovations attributed to this shipbuilding during the period, and it significantly improved their maneuverability compared to earlier square sails. The Dromon is also closely associated with one of Byzantine Empire's most famous military technologies, Greek fire. This incendiary compound, which could continue burning even on the water, was often projected from siphons mounted on the bow of this ship. While the exact ingredients of Greek fire are unknown, accounts describe its devastating impact during battles. The Byzantine fleets used the dromons to patrol the sea lanes, transport diplomats, escort merchant convoys, and even suppress piracy. Their combination of oars and sail allowed them to operate during calm conditions, and the shallow draft of some variants also enabled some coastal and estuary operations. Archaeological evidence on the dromons, though, is limited, as few complete wrecks have ever been found, but there's documents that, combined with partial wrecks and reconstructions, do allow historians to form a consistent picture of how these ships operated. The dromon was more than just a warship, it was a symbol of Byzantine maritime strength. Its influence can be seen in later medieval galleys used by Italian city-states, and in naval strategies that had shaped the European sea power for centuries. Number 6. The Mesopotamian bitumen-coated boat. Okay, that's really fun to say, the Mesopotamian bitumen-coated boat. Well, some of the earliest known boats capable of river and coastal navigation came from Mesopotamia, where civilizations like the Sumerians, the Akkadians, and Babylonians developed these distinctive bitumen-coated vessels. These boats, documented as early as the 4th millennium BCE, played an essential role in the economic development of this region, which depended heavily on river transport along the Tigris and Euphrates rivers. Now, Mesopotamian boats came in several forms, but many shared a common feature: hulls that were sealed with bitumen, which is a naturally occurring petroleum-based substance found throughout the Near East. It was applied thickly over reed bundles, wooden frames, or even planked hulls, depending on the type of boat, and archaeological sites like Ur, Babylon, and Mari have yielded remains of these bitumen coatings. One common vessel type was the kelek, or skin raft, made by stretching animal hides over a wooden frame and sealing them with bitumen. Larger cargo boats, however, were built using reed bundles bound into curved hulls, then coated entirely with bitumen to create a watertight surface. Mesopotamian texts describe a busy river-based economy. The Epic of Gilgamesh includes detailed references to the boat construction, and the administrative tablets from cities like Lagash and Uruk list quantities of bitumen that were allocated specifically for boat building. The records show that the boats weren't rare or ceremonial. They were essential tools for trade, irrigation, and communication between the city-states. Now, the waterproofing properties of bitumen gave the Mesopotamian vessels a notable advantage in a region where limited hardwood resources were. Reed was plentiful, easy to work with, and naturally buoyant, while the bitumen compensated for a weakness, the structure of it. This combination allowed the construction of large, functional boats without the need for extensive timber. These boats supported long-distance trade networks, they facilitated the rise of complex societies, and they influenced early boat-building traditions in the Near East. These vessels do represent some of the earliest examples of engineered watercraft, a major technological advancement in the ancient maritime history. Number 5. The Indus Valley Cargo Boat. The Indus Valley Civilization, circa 2600 to 1900 BCE, centered in what is now Pakistan and northwest India, developed a system of river and coastal transport. Although much about their maritime technology, though, is incomplete due to limited written records. But archaeological evidence from sites like Mohenjo-Daro, Harappa, and the important port of Lothal provide clear indicators of the types of boats they used. The Indus cargo boat in particular played a crucial role in trade along the Indus River and across the Arabian Sea. Excavations at Lothal, one of the world's earliest known dockyards, reveal a large brick-lined basin identified by archaeologists as a tidal dock. This structure dates to around 2400 BCE. It was connected by channels to the Sarvamati River and indirectly to the sea. While no full wooden boats have survived from that civilization, terracotta models discovered in Mohenjo-Daro and other sites do provide valuable clues. The clay models typically depict boats with long, narrow hulls and rounded sterns. Some show cabins or covered sections, implying that the boats carried cargo and crew. Some models show flat bottoms, ideal for navigating shallow rivers, and others feature curved hulls better suited to deeper water, and they suggest a variety of vessels that were adapted for different environments. The cargo boats were likely powered by paddles or poles on rivers and simple square sails when used in the Arabian Sea. The monsoon winds here would have made sail power practical for any coastal trading, and Indus merchants traded items like beads, pottery, ivory, copper, and textiles with regions including Mesopotamia, Bahrain, and Oman. And while some uncertainty remains about its structural details like the exact rigging systems or hull construction method, what is known firmly is based on archaeological evidence rather than speculation. The presence of standardized weights and measures combined with a dockyard system do indicate an organized maritime economy. Supported by these capable vessels, they've contributed significantly to the prosperity of one of the world's earliest urban societies. Number 4. The Celtic currach. The currach is one of the most enduring traditional boats of the Celtic world, used along the Atlantic coasts of Ireland, Scotland, and parts of Wales for at least 2,000 years. While today the currach is often associated with fishing and transport, historical sources indicate that early versions were used for some longer voyages, including travel between the British Isles and the European mainland. Traditional currachs were built using wooden framework of ribs and stringers that were lashed together with natural fibers. The hull was then covered with animal hides, which were typically ox or horse, stretched tightly and then sealed with tar or pitch to make the boat watertight. In later centuries, canvas replaced the animal hides, but the structural design did remain similar. Currachs, though, varied greatly in size depending on their intended use. Smaller versions were suited for short coastal trips and fishing, while larger ones could carry several passengers or cargo. Early references, like those by Roman writers, suggest that Celtic peoples used the skin-covered boats for trade and communication across the Irish Sea, and even the English Channel. And while these ancient accounts don't always specify the exact type of boat, archaeological evidence indicates that currach-like vessels were widespread. The design of it made it exceptionally buoyant and surprisingly seaworthy. The rounded hull could ride over waves rather than cutting through them, reducing the risk of capsizing. However, the currachs were light and easily affected by wind, requiring skilled handling in any open water. One of the most important modern demonstrations of currach seaworthiness came from Tim Severin's 1976 expedition, the Brendan Voyage. Using a reconstructed leather-hulled currach built with historical materials and methods, Severin sailed from Ireland to Canada via the North Atlantic, following the path described in the early medieval text Navigatio Sancti Brendani. While the journey is medieval rather than ancient, the voyage did prove that skin-covered currach-like boats were capable of long-distance ocean travel. The longevity of the currach's design itself is evidence of its effectiveness. Few ancient boat types have even remained in continuous use for so long. Number 3. The Austronesian Outrigger Canoe. The Austronesian outrigger canoe is one of the most important innovations in the global history of seafaring. It was developed thousands of years ago by early Austronesian-speaking peoples, likely originating from Taiwan and spreading through the Philippines, Indonesia, Micronesia, Melanesia, and even Polynesia. This vessel allowed humans to cross huge stretches of open ocean long before the invention of metal tools, compasses, or written navigation. Now, what sets it apart is the presence of 1 or 2 lateral support floats called outriggers or ama, attached to the main hull by wooden booms. This configuration prevents capsizing, even in heavy swell, and it allows canoes to be built long and narrow for speed. Double outriggers with floats on both sides are common in island Southeast Asia, while single outriggers are more common in Polynesia and Micronesia. The main hull was traditionally carved from a single log, breadfruit, coconut, or even other local hardwoods, then extended with planks sewn in or lashed in place using plant fiber rope. Outriggers were lashed tightly, but they were allowed slight movement, which distributed the stress and improved the boat's stability. The sailing rigs did vary across the region. Some outrigger canoes used a triangular or crab claw sail, while others used rectangular or spirit sails. These sails were woven from pandanus leaves or other plant fibers and extremely light, and it could be adjusted quickly. Some Austronesian canoes, such as the Micronesian proa, featured an asymmetric hull and a specialized sail that allowed them to shunt, which is reversing direction rapidly without turning the vessel around. To navigate these vessels, the ancient voyagers used a combination of environmental techniques: star paths, wave patterns, bird behavior, water coloration, and even wind consistency. The outrigger's stability allowed the navigators to read the cues accurately, even in rough conditions, and the canoe provided a space for fresh water, food supplies, tools, and sometimes livestock. In a historical context, the Austronesian outrigger canoe wasn't really merely a boat. It was a catalyst for cultural expansion. It is one of the most influential and successful boat designs ever created. Number 2. The ancient Greek merchant ships. Now, while Greek triremes dominate the popular imagination, the backbone of ancient Greek maritime trade was what was known as the holkas, a broad, deep-hulled merchant ship built to transport goods across the Aegean. Unlike warships, which prioritized speed, the holkas emphasized stability and cargo capacity. These vessels enabled movement of grain, olive oils, wine, ceramics, timber, and metals between the Greek city-states and its neighboring regions. These holkas ships were typically built using a mortise and tenon joinery method. In this system, wooden planks were cut with slots or mortises that fit tightly around projecting pegs or tenons. When pegged together, these planks formed a strong, watertight shell, and this construction method allowed the ships to withstand heavy loads and rough conditions. A holkas generally featured a single square sail mounted on a central mast. The mast was supported by stays and riggings, allowed the sail to catch prevailing winds efficiently. The hull of a holkas was wide and deep, provided excellent cargo capacity. Amphorae, the ceramic jars that were commonly used for transporting liquid goods, were often stacked in carefully arranged rows to maximize space while maintaining balance. Some larger holkas could carry several dozen tons of cargo, which was an impressive capacity for this period. Shipwrecks like the Kyrenia ship from the 4th century BCE give detailed insight into the arrangement of hull planking, cargo storage, ballast placement, and onboard tools. Now, holkas navigation was typically coastal, but the Greek sailors were skilled enough to make open sea crossings when necessary. Because the ships were built not for high-speed maneuvers, they avoided storm seasons and often traveled in convoys for safety. The holkas does deserve recognition as a critical component of ancient maritime economies. Its construction and large cargo capacity allowed the Greek civilization to flourish through extensive regional trade. It may not have been fast or as dramatic as a trireme, but in terms of historical impact, the holkas was far more essential. Number 1. The Roman grain freighter. The Roman navis honoraria is often referred to today as a Roman grain freighter. It was one of the largest and most important cargo vessels in the ancient world. These ships sustained the Roman Empire by transporting massive quantities of grain, olive oil, wine, and other goods across the Mediterranean. Unlike the sleeker warships of the era, the navis honoraria was built for capacity and endurance rather than speed. These ships had wide, deep hulls capable of carrying hundreds of tons of cargo. Some of the largest examples described in ancient texts could reach lengths of 40 to 50 meters and hold more than 1,000 tons, which was an astonishing number for a ship built over 1,800 years ago. Construction methods were the mortise and tenon joinery system, and the propulsion system of a grain freighter was based almost entirely on sail power. Many ships also carried a supplementary foresail that was mounted on a smaller mast near the bow, and unlike war galleys, which relied heavily on oars, these merchant vessels had no need for rowing crews. Ancient writers like Lucian and Strabo provided detailed accounts of the ships. Lucian, for instance, described a massive Alexandrian freighter named Isis, which showed its enormous size, its deep hull, and towering structure. Evidence supports the descriptions. Wrecks like ones off the French coast show the scale of the Roman merchant vessels, including hulls, extensive cargo holds, and the ballast systems. The impact of the navis honoraria on Roman civilization cannot be overstated. These ships fed an entire empire of millions that allowed cities to grow far beyond local agricultural capacity and supported an economy that stretched across 3 continents. In practical terms, they were the most important vehicles of daily life in antiquity.